Welcome to a session about best first search algorithm. Best first search algorithm is one type of informed search. So informed search uses domain knowledge. It, it uses the domain knowledge in the meaning of additional information leads the path to reach the goal node in a optimal way. So best first search algorithm is the combination of breadth first search and depth first search. These two algorithms are under uninformed search. Depth first search algorithm, what is the major advantage in the DFS algorithm is that to find the goal without exploring every state in the search space, potentially reducing the search effort. And breadth first search, what is the key advantage of breadth first search algorithm is that to avoid getting stuck in the dead end path by exploring all nodes level by level. So best first search algorithm contains both the advantages of DFS and BFS. So it is the combination of breadth first search and depth first search algorithm. It combines both the advantages. It selects the most promising path at each step, allowing it to switch between different paths and efficiently guide the search towards the goal and give the best solution. For the best first search algorithm, function value f of n only depends on heuristic value, that is h of n. So what is the procedure followed to find the optimal path or best path while using the best first search algorithm? Select the node that appears to the most promising based on the evaluation criteria. Okay, based upon the h of n value, select the promising node. Evaluate the selected node to determine whether it is better choice from the previously explored node. If the selected node does not lead to a better solution, return to the previous node and continue exploring alternative path through backtracking. So this backtracking is the important point while solving the best search problems. To support this process, alternative paths are retained even after choosing a move, allowing them to be revisited later if necessary. So list of nodes for the graph search. So there are two lists available. One is the open list and another one is the closed list. What is open list? So open list contains all the nodes that have been generated and evaluated using the heuristic function but have not yet been explored. It is typically implemented as a priority queue. Okay, so in the queue technique, many types are there. So here we are considering the priority queue. The priority queue arranges the nodes based on their priority, ensuring that the most promising node is selected for exploration first. And closed list, second type of list, closed list. This list stores the nodes that have already been explored and examined. Whenever a new node is generated, it is checked against the closed list to determine whether it has been previously visited, thereby avoiding redundant exploration. So in this best first search algorithm, f of n value equal to g of n. In the A star search algorithm, f of n equal to g of n plus h of n. So what is the g of n value? The cost of reaching from the initial node to the current node. H of n is the additional cost of getting from the current node to the goal state. Now consider this example. So from this example, you can get the idea how to solve the problem based upon the best first search algorithm, that is comes under the informed search. So here how many nodes are available? P, Q, R, S, T, U, V, W, X. So these are all the nodes available in this tree structure. So successor of P, Q, R, S, successor of R, T and U, successor of U, V and W, successor of W, X. And these values, okay, the values available in the diagram denotes the heuristic function value, nothing but h of n value. So P, the h of n value is 10 and S, h of n value is 8. Like this, all the values available for each and every nodes in the tree structure. So what is the steps followed to find the best path from the starting node to goal node? So first step, we have to create the two empty list. So we already know two lists available. One is the open list and another one is the closed list. Start from the initial node. From the diagram, what is the starting node? Starting node is the P and put it in the ordered open list. So repeat the next step until the goal node is reached or open list is empty. So what are all the steps we are following? Select the best node in the open list and move it to the closed list. Also take the information of the parent node. If P is the goal node, we have to check the node is goal node or not. Then exit the loop returning true. The solution can be found by backtracking the path. If P is not the goal node, expand node P to generate the immediate next nodes linked to P and add all those to the open list. Reorder the nodes in the open list in ascending order. So this is very important. Always we arrange the nodes in the ascending order based upon the h of n value. So h of n value lowest to highest value. Always we are exploring the lowest h of n value to reach the goal node. Always each and every step this reordering the nodes based upon the h of n is very important. So from this problem, the starting node, okay, initial node is P and what is the goal node? From the value in the diagram they are not mentioning anything. So we can consider P is the starting node based upon the h of n value. Okay, for the goal node always h of n value heuristic value equal to 0. So based upon that x is the goal node. From P to X, what is the best path? With the help of best first search algorithm, we have to find out. Now we can create the two lists. One is the open list, another one is the closed list. First, initially, we can take the first starting node P and write the corresponding h of n value 10. So then we can move this P to closed list. Then explore the P. What are all the successor for the P? Q, R, S. So Q, the corresponding value h of n is 9. R, the corresponding value is 7. S, the corresponding value is 8. So then what is the next step? Immediate next step, we can reorder the value. Okay, we reorder the nodes based upon the h of n value, lowest value to highest value. So from this, which one is the lowest value? Node R. So R 7, S 8 and Q 9. So from this, what is the least value? H of n node will be shifted to closed list. Okay, so next node R shifted to closed list from the open list. So then explore R value. Okay, so exploring R value. So R connected with T, okay, and R connected with U. Okay, successor of R, T and U. So then explore these two values and put it in the open list. So now our value is What are all the values? Explored value, T value is 8 and U is 6. What is the immediate next step? We have to write the value in the ascending order based upon the h of n value. So from this least value is 6. That is for node U. So node U6 and S8, T8, Q9. So what is the next step? We can move U from the open list to closed list and explore U value. Okay. So successor of X, successor of U is U1, V and W. Okay. So then we can write these two in the open list. V has the heuristic value of 6, W has the heuristic value of 3 and put the values, put the nodes in the open list. So now immediate next step, write all the values in the ascending order. So compare all the values, which is the minimum value W. Okay, W3, V6 and S8, T8 and Q9. Now what is the next step? And we are moving that least value node from open list to closed list. So W moved from open list to closed list. So now P R U W. So then expand or explore W. So W connected with X. So then we can keep that X value in the open list having the h of n value 0. So immediate next step, we can arrange the value. Reordering is very important. That reordering will be based upon the ascending order. Now x is equal to 0, V6 and S8, T8, Q9. Now what is the next step? We can move the x from open list to closed list. So then we can have the closed list. What are all the values? What are all the nodes available in the order P, R, U, W, X. Okay. So best path from the initial node or root node from P to X using the best first search algorithm based upon the lowest heuristic value to reach, to provide the optimal path, best path from the starting node to goal node is P to R, R to U, U to W, W to X. So this is the procedure followed to use the best first search algorithm to find the path, best path from the start node to end node. So we consider another example. Let us see the another example to get familiarized about the best first search algorithm. So in this best first search algorithm, we consider only the heuristic value alone. Okay, we don't consider that g of n value. So consider this diagram. The diagram, near to the diagram, the sum of values are available. These values are called as path cost value. So these values will be used to calculate g of n value that will be useful for solving the problem with the help of A star search algorithm. But in the best first search algorithm, we consider only heuristic value alone. This heuristic value tabulated in this tabulation. So home 120, bank 80, garden 100, school 70, railway station 20, post office 110, police station 26. So now home is the initial location and university is the end location. Okay, goal location. Okay, so our aim is we have to travel from home to university with the help of best first search method to get the optimal path. So from the home, we can see that the home connected with bank, home connected with garden, home connected with school, and we can write the corresponding heuristic value 80, 100, 70. So from this, what is the least value? we can choose the lowest heuristic value path. So home to school, 70 is the least value. So then expand school, school connected with railway station, school connected with the post office with the heuristic value, railway station heuristic value 20, post office heuristic value 110. So now we can see all the leaf values. Okay. So here the value is 80, 100, 20 and 110. So what is the least value, lowest value of h of n is 20. So then expand railway station. So then railway station connected with the university, that is the end location based upon our problem. So then while applying the best first search algorithm, the path will be home to school, school to railway station and railway station to university. Algorithm. Thank you.